So I'm going to apologize because my slate's not working right. So I'm using my mouse pad to write. So when you factor, you always first look for the GCF. If I look, there's a 2. Two can go into all of the coefficients, and they all have an A. So my GCF is 2A. And if I divide each one by 2A, the 2's cancel, the A's cancel, left with B. Well, that looks bad, sorry. Plus, the 2 cancels, the A cancels, left with C. Plus, 4 divided by 2 is 2, and A squared divided by A is A. Then there's nothing more that you can factor. All right, so we really haven't done a whole lot with cubes. I'm going to make a separate video with just some special factoring, just so you guys kind of can see that. But anytime you see a cube here, you want to think what number cubed is 64? And that's going to be 4. So think of 64 as 4 to the third. And as soon as you can get both exponents to be cubed, the first parenthesis is just everything without the cubes, so x plus 4. Then there are 3 pieces. This is the most different than what we've done before. 3 pieces in the second parenthesis. Whatever first here, square the first, and that's the first one. Square the last one. 4 squared is 16. That's the last one. Then just multiply these two together. 4x. And it's always, there's only one minus sign. So if this is plus, this is minus. If the minus either goes in the middle or it goes right away. Okay, this is the most basic of factoring. We call this the difference because we're subtracting the difference of 2 squares. And you've seen this quite a bit in the last week. So there's no GCF, so automatically do 2 parentheses. X and X. Y squared comes from Y and Y. This is an X. 1 is a plus, 1 is a minus. The cube is not as important. The square's really important. So every time these are squares with a minus sign, you just break apart the first one, break apart the last one. One's a plus, one's a minus. In order to do all rational functions, you have to be able to factor. Okay, so I started out with some easy ones. In order to add or subtract, you need a common denominator. So these are all add or subtract, and they all have a common denominator. So once you have a common denominator, add the numerator. 7 plus 9 is 16, all over the common denominator of 4x. Now, 16, the factors of 16, 4 and 4. So any factor from the top can cancel any common factor from the bottom. So my final answer should be 4 over x. So that's the tough part about add and subtract. Not only do you have to add and subtract, you should always check to see if your final answer is simplified. Number 5 has a common denominator, so you go straight across. 5 plus x. Well, 5 and x are not like terms, so I can't add them together. I just leave them as a separate term. and there's nothing I can do. Now, remember, this plus connects the 5 and the x together. This is all one factor on the top. This is all one factor on the bottom because of this plus, and so nothing can cancel. 5 plus x is different from x plus 1, so I just leave it alone. We have a common denominator. They both have x plus 3, so I just go straight across. 2x minus 1. 2x and 1 are not like terms, so I cannot combine them. All over x minus 3. So once you have a common denominator, add or subtract the numerator, keep the denominator. So finding the common denominator is the hardest part. So we make up the common denominators using common factors. This is where I keep saying factor, 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 factor. Now, we have to really look at this in pieces, though. I need to compare the factors of the first fraction to the factors of the second fraction. So first, the first fraction is already factored. My denominator, x plus 1. My second denominator, this is the difference of two squares. So I need 2 parentheses, x and x plus 1 minus 1. 1 is a perfect square, so 1 and 1, 1's a plus, 1's a minus. All right, for my least common denominator, I need to make the denominators the same. Notice this denominator just has x minus 1, so I need a factor of x minus 1. Then when I look at this denominator, I need to see what am I missing. See, I already have the x minus 1. I just need x plus 1. This does not ask us to add or subtract. We are just finding the common denominator. So if I compare my two denominators, what I would normally do is just multiply this one by x plus 1, top and bottom, to get a common denominator. So notice that's why my least common denominator, I need an x plus 1 and an x minus 1. Number 8 is very similar. So I need to factor the second denominator, x and x plus 4 minus 4, difference of two squares. So my least common denominator, basically kind of what I do, I write down the first denominator, x plus 4. Then I look at my second denominator and ask myself, what is missing from my least common denominator that I see in my second denominator? I am missing an x minus 4. All right, number 9, compare the denominators. Notice this is not factored. Anytime there's an x squared, this isn't factored. So I'm going to factor this out, x and x. I need factors of 2 that subtract to get 1. So plus 2 minus 1. Now I'm going to be real honest here. When you go to factor, if you can't factor, look at the other denominator. More than likely, almost every time they should have something in common. So sometimes that can help. So my least common denominator, I need this entire denominator, x plus 2 times x minus 1. Then when I jump to this side, Do I already have an x plus 2? Yes, so I don't need another one. This is my entire least common denominator. Now, in number 10, it's all been factored. So the only thing I need to do now is list my least common denominator. Now notice they all have a 2. Okay, we'll write down all of the first denominator. 2x plus 1. When I jump to my next denominator, think of all these as separate pieces. My two factors in this denominator are 2 and x. I already have a 2, but I don't have just a plain x. This x is connected to the plus 1. So I also need a plain x. Then when I jump to this one, I already have a 2. What does x plus 1 squared mean? That means x plus 1 times x plus 1. That means in my least common denominator, I need 2 x plus 1s. Right now, I just have 1. So you can either write it out as x plus 1, or you can just make it easy and square the x plus 1. All right, the next 9 are just simplifying. I've kind of mixed it up, so there's some add, some subtract, but even some multiply, divide, and simplify. So pay attention to what's in between the fractions. Since this is a plus, with a plus we need a common denominator. So I need to make my common denominators out of my current denominators. So I need an x. Now, sometimes I think it's almost easier rather than writing out the least common denominator. It's just comparing the two. What does one have that the other one doesn't? See how this one has a 3? That means this one needs a 3. So anytime you multiply, you have to multiply the top and the bottom by the same thing. So since this side needs a 3, I multiply the top and bottom by a 3. Now, if I compare my x's, this has an x, but this has an x squared. I need them to be both the same. So that means I need to multiply this side by an x on the top and an x on the bottom. If I take 3 times 5 times x, that's 15x over the denominator. X times 3 times x is 3x squared. I'm going to apologize because as I was doing the worksheet, I didn't have very much room. So I'm sorry about that. I'm going to write this all out. You might do it in smaller phases, and that's okay. So the first thing I did was get a common denominator. Now this problem is just like 4 through 6, where you start with a common denominator. We just add the numerator, keep the denominator. Because the 15 has an x and the 2 is a constant, I can't add them together. I just leave them as separate pieces, all over the same common denominator of 3x squared. In number 12. All right, so let's just take this in pieces. If this has a plain 2, I need to multiply top and bottom here by 2. So they all have a 2. I'm going to multiply top and bottom here by 2. Now, this has an x, but this has an x squared. I need everything to be the same, so they all need to have an x squared. So I'm going to multiply the top of this by x squared and the bottom of this by x squared. Then I'm going to multiply this one by just as plain x because it already has an x, so I just need to multiply by one more x because my common denominator is going to be 2x squared. So if it's easier for you to find your least common denominator first and then multiply by what you're missing, that's fine too. Our goal is that all denominators will be the same. Then if I take x squared times 1, that's x squared. 2 times 2 times x is 4x. 3 times 2 is 6. So now I have a common denominator of 2x squared, and I get x squared plus 4x minus 6. And I have no like terms, so I just leave it as my final answer. All right, let me move this over a little. Okay, so the first thing you should notice in 13, it's a times problem. When we are multiplying, we don't need a common denominator. We just need to factor. Factor each numerator and each denominator. So in number 3, or the numerator here, it has a minus sign, so I need to either look for a GCF or I need 2 parentheses. If it has a minus sign, look for the GCF first. There's a GCF of x, so divide out the x. If I take an x away, what am I left with? 3 minus y. Now, this doesn't have a minus or a plus, so I can just list each factor separately. The factor of 6 is 2 times 3. X squared is x times x, and the y is just by itself. So what's really important here to me, that you notice if there's a minus, you're going to need parentheses. If there's not a plus or a minus, you list each one separately. Notice in this denominator, there is a minus. There's not a GCF, so I need 2 parentheses. All of this is just being multiplied. Break apart the y squared, y and y, plus 3 minus 3. All right, since we are multiplying, I'm just really multiplying everything on the top together, everything on the bottom together. Everything is being multiplied. So any common factor from the top can cancel any common factor from the bottom. So this plain x can cancel a plain x on the bottom. This plain 3 can cancel this plain 3 on the bottom. Now, we have to be careful. This is 3 minus y on the top. It can cancel this y minus 3 on the bottom, but when the order is reversed with minus, I need to leave a negative sign. So this can cancel out this one,